February 23, 1943. Telefunen headquarters, Berlin. The magnifying glass trembled slightly in Obstetl hand as he examined the copper block salvaged from the wreckage 3 weeks earlier. "This cannot be real," he wrote in his classified technical report. No nation could achieve such miniaturization while simultaneously producing such power output. Through the laboratory windows he could see the smoke rising from the bombed factories across the city. Tangible evidence of Allied air superiority. Yet here on his workbench lay physical proof that the technological gap was far worse than anyone in the German High Command had dared to admit. The device before him, retrieved from a downed British Sterling bomber near Rotterdam on the night of February 2nd, measured barely 10 centimeters across. This cavity, magnetron as the British called it, generated microwave radar frequencies that rendered every German countermeasure obsolete. It was elegant in its simplicity, devastating in its implications, and utterly beyond anything German science had achieved. What neither Runge nor his colleagues yet understood was that this single copper block would explain a mystery that had been costing Grand Admiral Karl Donitz 40 submarines per month. Hemorrhaging of men and machines that threatened to lose Germany the Battle of the Atlantic within weeks. The mathematical certainty of German defeat was being written not in naval strategy but in electromagnetic wavelengths that German radar detectors could not see. The psychological transformation had begun. On that freezing February morning in Rotterdam, Dutch resistance members had watched German soldiers cordoning off the crash site with unusual urgency. The Sterling bomber, serial number R9264 from 7 Squadron RAF, had been returning from only its second operational mission when flak had torn through its port wing. The crew of 7 had died instantly in the crash, but their sacrifice would prove more valuable to the Allied cause than they could have imagined. The aircraft carried Britain's newest secret weapon, the H-2S ground mapping radar system, designed to allow bombers to navigate and identify targets through cloud cover and darkness. At its heart lay the cavity magnetron, a device so revolutionary that Winston Churchill himself had agonized over its deployment, fearing exactly what had now occurred. The bomber had been part of a raid on Cologne following H-2S radars. Combat debut against Hamburg just 3 days earlier on January 30, 1943. General de Luftner Wolfgang Martini, chief of Luftwaffe Signals Intelligence, and one of Germany's most senior radar experts, was alerted to the crash within hours. As the officer responsible for all German radar development and signals intelligence, Martini understood immediately that the Rotterdam crash might provide answers to questions that
They wanted a high-altitude interceptor capable of matching the Luftwaffe's best. What Cartelli designed instead was a monster that redefined the possible. It will be a dinosaur, Cartelli admitted to his design team. But it will be a dinosaur with good proportions. The XB-47B prototype that first flew on May 6, 1941 shocked everyone who saw it. At 9,900 empty, it weighed 65% more than its predecessor, the P-43 Lancer. The massive turbo supercharger system, with its complex ducting running through the rear fuselage, gave it an almost pregnant appearance. Test pilots approaching it for the first time invariably asked the same question. This thing actually flies. Not only did it fly, it flew like nothing else at altitude. The Pratt & Whitney R2800 double wasp engine, an 18-cylinder radial, producing 2,000 horsepower, could maintain full power at 27,000 feet where German fighters gasped for air. The turbo supercharger, fed by exhaust gases, delivered sea-level performance in the stratosphere where the air was too thin for conventional superchargers. Major Hubert Hubsgaw, commanding the 56th Fighter Group training at Bridgeport, Connecticut, initially despised the aircraft. His unit lost 18 pilots and 41 aircraft in training accidents between September 1942 and January 1943.
Had been haunting German commanders for months. His position as head of the Luftwaffe's entire communications and radar infrastructure made him uniquely qualified to assess whatever technology the British bomber might contain. Martini dispatched his most experienced technical teams to the crash site. Their initial reconnaissance confirmed his worst fears and greatest hopes simultaneously. The bomber's belly contained equipment unlike anything German forces had encountered. The rotating antenna, assembly, the cathode ray display system, the sophisticated power supply, all pointed to advanced radar technology operating on principles that German engineers had theoretically discussed, but dismissed as impractical for operational deployment. But when his technicians carefully extracted the transmitter assembly from the wreckage, examining the component that powered this mysterious system, what they found defied German understanding of physics and engineering. The magnetron itself, British model CV-64, consisted of a solid copper cylinder, approximately 8 centimeters in diameter and 12 centimeters long. 8 cylindrical cavities had been precision machined into the copper, arranged symmetrically around a central cathode. The entire assembly was surrounded by powerful permanent magnets. It was deceptively simple in appearance. Yet initial field tests suggested it generated enormous microwave power at frequencies German equipment could neither produce nor detect reliably. Martini ordered the device transported immediately to Berlin, under armed guard. He had seen enough to know this discovery might explain why Donitz's Hubert were dying at unprecedented rates. The British had achieved something German science had declared impossible. A compact, powerful, microwave radar system that could be mounted in aircraft and ships, providing detection capabilities against which Germany had no defenses and no countermeasures. The journey from mystery to revelation had actually begun months earlier in the gray waters of the North Atlantic. Throughout late 1942 and early 1943, U-boat commanders had been reporting increasingly disturbing encounters with Allied aircraft that seemed to possess supernatural detection abilities. Kapitan Lit Hans Joachim Schiwanka, commanding U-43, had filed a report in December 1942 that typified the growing crisis. His boat had been transiting the Bay of Bisque on a moonless night, running on the surface to recharge batteries when searchlights had suddenly blazed from directly overhead. There had been no warning from the MTOX radar detector, no engine noise, nothing to indicate an aircraft's approach.
A 20 mm shell had exploded in the canopy track, welding it shut. He was trapped in a dying aircraft at 27,000 feet. What happened next defied every assumption about combat damage tolerance. Despite having no forward visibility through the oil-covered windscreen, a barely functioning engine that shook violently, and controls that responded only intermittently, Johnson managed to level the aircraft and point it toward England. The P-47 continued flying with damage that would have reduced any other fighter to falling debris. Then it got worse. A lone Focke-Wulf 190 flown by An unknown pilot from 2/JG-26 discovered the crippled Thunderbolt, limping toward the channel at less than 170 miles per hour. Historical research has never definitively identified this pilot, though several names have been proposed based on German combat reports from that day. What followed was one of the most extraordinary encounters in aerial warfare history. The German pilot positioned himself behind Johnson's P-47 and opened fire with his 420mm cannon and two 13mm machine guns. Johnson, unable to evade, could only huddle behind his armor plate and pray.
Depth charges had bracketed his diving boat, causing severe damage that forced an emergency return to port. "We were blind," Schwanke wrote in his war diary. The Metox gave no alarm. The aircraft appeared as if materialized from darkness itself. Only luck saved. "We heard the bombs falling and crash-dived with seconds to spare. Detector should have warned us minutes in advance, giving us time to dive safely. Instead, we had no warning at all. Either the British have developed radar our detectors cannot sense, or they are using some other technology we do not understand. Whatever the explanation, we are being hunted by enemies we cannot detect until the moment of attack." Similar reports flooded into U-boat headquarters in Paris. Throughout the winter, boats were being caught on the surface at night with no warning. Aircraft seemed to see through darkness and weather that should have provided cover. The MTOX radar detectors, which had given U-boats advanced warning of aircraft equipped with older ASV Mark II radar systems operating at 1.5 m wavelengths, had become worse than useless because commanders still trusted them to provide adequate warning. The statistics told a grim story that would become catastrophic by spring. In November 1942, German U-boats sank approximately 119 merchant ships totaling 729,000 tons worldwide, losing 13 submarines in return. December saw 60 merchant ships totaling 330,000 tons sunk, with 5 U-boats lost. By January 1943, sinkings dropped to 37 ships while U-boat losses climbed to 7. February saw 34 merchant ships sunk and 17 U-boats lost. The exchange rate, once heavily in Germany's favor, was collapsing at an accelerating pace. Admiral Karl Donitz, promoted to Commander-in-Chief of the entire Marine on January 30, 1943, while retaining direct control of U-boat operations through his subordinate staff, watched these numbers with growing alarm. His headquarters maintained detailed plots of every U-boat position, every convoy route, every engagement. The patterns emerging from these plots made no sense according to conventional naval warfare logic. U-boat approaching convoys in darkness were being intercepted before they could attack. Boats transiting the Bay of Bisque under cover of night were being bombed with precise accuracy. Submarines running submerged during daylight were somehow being tracked and depth-charged. Allied aircraft appeared to possess supernatural ability to locate submarines in conditions where visual detection should be impossible. The weather conditions during many attacks ruled out visual detection entirely. Yet, the attacks came with devastating precision. Corvette and Capitan G.A. Hessler, Donitz's son-in-law, who had married his daughter Ursula in November 1937, served as first staff officer at U-boat headquarters. Hessler spent weeks analyzing combat reports, seeking explanation for the mysterious losses. The pattern was clear but incomprehensible. Allied detection capabilities had improved dramatically over a very short period between late 1942 and early 1943, suggesting new technology rather than improved tactics or training. But what technology could see through darkness, clouds, and fog? What could detect a submarine's small conning tower from miles away? What could track a periscope wake or snorkel exhaust in conditions where human observers would be completely blind? The questions multiplied faster than answers could be found. Donitz convened crisis meetings with Germany's top scientists and engineers throughout January and February 1943. The discussions revealed disturbing ignorance about Allied capabilities and troubling complacency about German technological superiority. German radar experts insisted that no radar system could effectively operate at wavelengths shorter than about 50 centimeters, due to fundamental power generation limitations. The vacuum tube technology available, they argued, simply could not generate sufficient power at higher frequencies to make shorter wavelength radar practical for military applications. The MTOX detectors designed to detect Allied radar operating at 1.5 m wavelength should theoretically warn of any radar-equipped aircraft. The system worked by detecting the electromagnetic emissions from aircraft radar, giving Hubert several minutes warning to crash dive before the aircraft could close to attack range. Yet clearly they were not providing adequate warning anymore. Something had changed in Allied capabilities. But what? Some scientists speculated that the Allies had developed infrared detection systems that could sense engine heat from U-boat diesel exhaust. Others suggested acoustic detection, though this seemed implausible at the operational distances involved. A few voices mentioned the theoretical possibility of centimetric radar using advanced magnetron technology, but this was dismissed as impractical. Germany's own research into such systems had concluded they offered no tactical advantage worth the enormous development investment required. The British could not possibly have solved problems that had defeated German engineering. The experts assured Dunit German science was the best in the world. If German engineers had concluded centimetric radar was impractical, then it must be impractical. The Allies must be using some other approach, perhaps multiple detection methods working in combination. The idea that Britain, suffering under years of strategic bombing with its industrial base under constant attack, could have developed revolutionary radar technology superior to anything Germany possessed seemed absurd to many German experts. This complacent certainty would shatter completely when Runge's team at Telefunen began examining the Rotterdam device. The magnetron arrived in Berlin on February 5, 1943, accompanied by photographs of the complete H-2S installation and detailed reports from the crash site. Runge assembled Germany's top microwave specialists for what would become known as the Rotterdam Working Group, or Arbeitsschaft Rotterdam. Their task was to determine exactly what the device was, how it worked, and most critically, what capabilities it provided the Allies. The first meeting of this working group would occur on February 22nd or 23rd at Telefunen's Berlin offices.
In January 1944, a new variant of the P-47 began arriving in England that would complete the transformation from laughingstock to nightmare. The P-47 D-22 featured a Hamilton standard hydroatic propeller with paddle blades 13 feet in diameter with broad chord blades that bit into the air like massive OES. The improvement in climb rate was immediate and dramatic. Where earlier Thunderbolts had climbed at an anemic 2,200 feet per minute at sea level, the paddle blade variants could achieve 3,000 feet per minute, matching or exceeding German fighters at most altitudes. The massive propeller also improved acceleration, allowing P-47s to build energy faster in level flight. Hedman Heinz Knoker of Jagdgeschwader 11, a veteran with over 200 combat missions, encountered the new variants in February 1944 during a bomber interception near Hanover. He wrote in his combat diary, "The fat American fighters have learned to climb. We bounced a formation near Hanover, expecting our usual advantage. They turned into us and climbed with us. When we tried to disengage, they followed us up to 30,000 feet. Schmidt was caught and blown apart. Nothing left but smoke and fragments. These are not the same machines we laughed at last year." The paddle blade propeller did more than improve performance. It changed the sound of the Thunderbolt. The distinctive thundering roar created by the blade tips reaching supersonic speeds could be heard from miles away. German ground troops reported being able to identify approaching P-47s by sound alone. A deep threatening rumble that meant death from above. They began calling it Donnerschlag thunderclap.
The initial examination on February 6th revealed the magnetron's basic operating principle. Within hours, the cylindrical cavities acted as resonant chambers, generating and amplifying electromagnetic oscillations. As electrons spiraled through the magnetic field created by the permanent magnets, it was conceptually similar to earlier splitter node magnetron designs that German engineers had experimented with in the 1930s, but executed with a level of engineering sophistication that shocked the German team. Dr. Otto Hakenberg, a young physicist assigned to document the examination, would later recall the moment of realization in interviews conducted after the war. When we first energized the magnetron using laboratory power supplies, the frequency counter registered 3.3 gigahertz, a frequency we could barely measure, let alone generate with any power. The output meter showed 40 kilowatts of peak power. It was like discovering the enemy-possessed artillery when you thought the battlefield limited to rifles. We understood immediately why the MTOX was useless. It was built to detect meter-wavelength radar operating around 1.5 m or 200 megahertz. This device operated at 9.1 centimeters. Wavelength, more than 16 times shorter. Our detectors were completely deaf and blind to this radiation. The electromagnetic spectrum the British were exploiting was entirely outside the range our warning receivers could detect. We had been fighting blind, unaware that the enemy could see us clearly while we saw nothing. Runge's team worked around the clock for 2 weeks, reverse engineering the complete H2S system from the wreckage and the recovered components. The magnetron powered a rotating antenna that scanned a 360 degrees arc beneath the aircraft. Returns appeared on a plan position indicator cathode ray display, creating a map-like image showing coastlines, cities, rivers, and terrain features with remarkable clarity. For the first time, bomber crews could navigate and identify targets in complete darkness or through solid cloud cover. The system had been designed primarily for strategic bombing navigation, allowing Pathfinder aircraft to mark targets for following bomber streams regardless of weather conditions. British bombers could now attack Germany in weather that had previously provided natural protection. But the implications for submarine warfare were even more profound than the bombing applications. The same cavity magnetron technology, adapted for air-to-surface search radar designated ASV Mark III, could detect a submarine's conning tower from 20 m away in any weather day or night. The small radar cross-section that had previously protected submarines from detection meant nothing against this sensitive, high-frequency system operating in the centimetric wavelength band. Worse yet, the microwave emissions were completely undetectable by German radar warning receivers. All existing German detection equipment, including the MTOX system that U-boat relied upon, operated in the meter wavelength range. The MTOX could.
I was the only one to return. The P-47s were waiting at every altitude. You couldn't climb over them. Couldn't dive under them. Their guns turned our fighters into aluminum rain. In the weeks following D-Day, P-47s systematically destroyed German movement in daylight. The statistics were staggering. In June alone, 9th Air Force Thunderbolts claimed 651 locomotives, 3,847 trucks, 512 tanks and armored vehicles, and 4,553 horse-drawn vehicles destroyed. The Wehrmacht was forced to move only at night, severely hampering their ability to respond to Allied advances. The Germans tried everything to counter the Thunderbolt threat. They reinforced vehicle armor, deployed more anti-aircraft guns, developed new camouflage techniques. Nothing worked. The P-47's combination of speed, armor, and firepower made them nearly unstoppable. Even the feared 88mm flak guns struggled to track the fast-moving fighters at low altitude. While devastating Europe, the P-47 was simultaneously proving its worth in the Pacific theater. The 348th Fighter Group, operating from New Guinea, discovered that the Thunderbolt's qualities were perfectly suited to the vast distances and harsh conditions of the Pacific War. Colonel Neil Kirby, commanding the 348th, developed tactics specifically for the Pacific. On October 11, 1943,
detect radar operating between 1.3 and 2.6 m wavelength, covering the frequency range of ASV-M2 radar that had equipped Allied aircraft through 1942. But this new centimetric radar operated at 9.1 centimeters, a frequency 17 times higher than anything German warning receivers could detect. Hubert were running blind into enemy attacks, their defensive systems obsolete without their knowledge. The technological surprise was complete and devastating. On February 23, 1943, the Rotterdam Working Group presented their findings to German military and industrial leadership. While no documentary evidence confirms the personal attendance of either Reich Marshal Hermann Göring or Admiral Dönitz at this technical working group meeting, both were certainly briefed on the findings. Representatives from every major German electronics firm attended, including engineers from Telefunen, Siemens, AEG, and Lorenz. Senior Luftwaffe signals officers and marine technical specialists filled the conference room at Telefunken headquarters. The mood was somber. Runge began his presentation with a statement that would be recorded in the minutes and later recovered by Allied investigators after the war. We must report with complete frankness that the British have achieved a technological breakthrough of extraordinary significance. The cavity magnetron represents an advance in microwave generation that exceeds German capabilities by at least 3 years of normal development. More critically for current operations, the device enables radar detection systems against which we have no countermeasures and no defenses. The presentation detailed the technical specifications of the CV-64 magnetron, 8 resonant cavities machined into a copper block, operating at 3.3 GHz frequency with 9.1 centimeters wavelength, peak power output of 40 kW, compact construction suitable for aircraft installation, robust design, capable of withstanding combat conditions, production quality indicating established manufacturing processes rather than experimental prototypes. The implications were devastating. If the British could manufacture these devices in quantity, and the production quality suggested they could, then every Allied aircraft and ship could potentially be equipped with radar systems against which Germany had no defense. The MTO warning receivers were useless. The extensive network of German radar installations operating in the meter wavelength range would be increasingly obsolete. German night fighters, German anti-aircraft defenses, German naval vessels all relied on radar technology that the British had leapfrogged by an entire generation. When Göring was briefed on these findings, possibly at the Humboldtine Flak Tower in Berlin, where the reassembled H-2S system was demonstrated, his reaction was reportedly one of considerable consternation. The Reichsmarschall, who had boasted in 1939 that no enemy aircraft would ever bomb Germany, now faced evidence that British bombers could navigate and bomb in any weather conditions using technology Germany could not match. Dönitz, when briefed through his staff channels, understood the implications more clearly than anyone else in the German High Command. His U-boat force had lost 39 submarines in the first 2 months of 1943, 17 in January and February combined.
By tomorrow, we'll have 40 new ones. How long will it take you to replace your pilots? The German pilot's smirk disappeared. Within 48 hours, factory-fresh P-47D-40s filled the flight line. Flown in from depots in England, the Luftwaffe lost 271 aircraft and 213 pilots in Boden-Platter, including many irreplaceable instructors and squadron leaders. These losses they could never replace. The Americans lost 134 aircraft total across all attacked airfields, all replaced. Within a week, the numbers told the story of inevitable defeat. Republic Aviation produced 15,683 P-47s during the war, more than any other American fighter. At peak production, the Farmingdale factory on Long Island completed one Thunderbolt every hour around the clock. The Evansville plant in Indiana, built from empty farmland in 1942, was producing 500 aircraft per month by 1944. Each P-47D required 65,000 individual parts, 8 miles of electrical wiring, 2,000 pounds of aluminum, and 300 pounds of rubber.
Though records show 7 in January and 17 in February for a total of 24 with additional boats lost in December, bringing recent losses to 39 over the 3-month period. If this trend continued, the U-boat campaign would collapse within months. Kapitan Zur Ebehadgit, who served as Donitz's operations chief and had been promoted to Contadmiral in March 1943, maintained detailed statistical analysis of U-boat operations. The numbers told an increasingly grim story. In the first quarter of 1943, German U-boat were being lost faster than they could be replaced, despite shipyard production running at approximately 20 to 24 boats per month. More critically, experienced crews were dying faster than training programs could replace them. The meeting attendees reached several sobering conclusions that were documented in classified reports later captured by Allied forces. First, Germany could not replicate the cavity magnetron in operationally significant numbers before 1944 at the earliest. The precision machining required to create the resonant cavities, the specialized copper alloys, the powerful permanent magnets using cobalt that Germany lacked in sufficient quantities, and the manufacturing expertise required were all beyond immediate German capabilities. Even a crash program would take months to establish production lines. Second, developing effective countermeasures would require at minimum 6 months. A new generation of radar warning receivers tuned to centimetric frequencies could theoretically be designed, but production and installation across the entire U-boat fleet would extend well into 1944. The technical challenges of building receivers that could detect 3.3 GHz emissions were formidable given Germany's limited experience with microwave technology. Third, and most devastating, the British almost certainly had variants of this technology beyond what was captured. The Rotterdam device operated at 9.1 centimeters. Allied scientists likely had already developed or were actively developing 3-centimeter systems that would render even new German countermeasures obsolete before they were deployed. The technological race was not merely lost. It was unwinnable in the war's current time frame given the Allied head start and superior industrial capacity. Dönitz absorbed these briefings with growing understanding of the catastrophe facing his command. His U-boat headquarters, which had relocated to the Paris area in March 1942 after the St. Lazare commando raid exposed the vulnerability of the previous Laurent location, maintained detailed plots of every engagement, every loss, every tactical development. The maps on the operations room walls told the story more clearly than any statistical analysis. Red pins marking U-boat positions had thinned dramatically across the North Atlantic. Blue pins indicating Allied convoys seemed to flow through areas where wolf packs should have intercepted them. Black pins, the markers of U-boat losses, clustered along transit routes through the Bay of Bisque and in the operational areas where boats encountered Allied air patrols. "We have been fighting blind," Dönitz told his senior staff in briefings following the Rotterdam device examination. "Every advantage we believed we possessed has been neutralized by Allied technology we did not know existed. Surprise attack at night meant nothing, when the enemy could see in complete darkness. The vast expanse of the Atlantic provided no concealment when radar could detect a conning tower from 20 m away.
The sound haunts us. Mechanical, precise, unstoppable. Like everything American, it's about overwhelming material superiority. They didn't beat us through better tactics or braver pilots. They buried us under an avalanche of steel and lead. By April 1945, the Luftwaffe existed largely on paper. Fuel shortages grounded most aircraft. Experienced pilots were dead or captured. Airfields were cratered ruins. But even with aircraft and fuel, German pilots faced an impossible equation. Attacking meant facing P-47 formations that owned every altitude from ground level to 40,000 feet. Felled Webel Klaus Brechner, one of the last German pilots trained in 1945, flew exactly one combat mission before the war ended. His encounter with P-47s over Leipzig lasted 12 seconds. I saw them diving from above, 4 Thunderbolts in perfect formation. I tried to turn, but they were too fast. The leader fired from 500 m. My aircraft shook like it was hit by sledgehammers. The engine exploded, the wings separated. I barely escaped. In the parachute, I watched them destroy my entire staff. 6 fighters gone in under a minute. The sky rained, burning aluminum and bodies. The psychological impact was complete. German pilots developed what medical officers called Jabo fever, physical symptoms of stress appearing when Thunderbolts were reported in the area. Veterans who had faced Spitfires and Hurricanes without fear became physically ill before missions against P-47s. The distinctive thunder of approaching Thunderbolts caused panic among ground troops who knew that survival meant finding cover immediately. The final statistics of P-47 operations defied comprehension. In Europe, 3,752 German aircraft destroyed in aerial combat.
Sailing together through the North Atlantic in mid-March were attacked by approximately 40 U-boat from 3 Wolfpacks. The battle raged from March 16 to 20, 1943. 21 merchant ships totaling 141,000 tons were sunk, the highest losses from any single convoy battle of the war. The British Admiralty issued an internal assessment that Germany had never come closer to severing Britain's Atlantic lifeline, but the cost to Germany was unsustainable. The U-boat attacking these convoys lost one boat definitively, U-384, with several others damaged. However, the broader March statistics showed 12 to 15 U-boat lost during the month, depending on classification methodology, with many losses occurring in areas outside the major convoy battles. The mathematics were inescapable even when achieving tactical success in sinking merchant ships. The strategic picture was deteriorating. Allied shipyards, particularly the rapidly expanding American construction program, were producing merchant vessels faster than U-boat could sink them. The Liberty ship program had reduced construction time from over 200 days in 1941 to an average of 42 days by 1944. While individual ships like the SS Robert E. Epperey were built in record time, 4 days, 15 hours, and 29 minutes in November 1942, these were propaganda achievements rather than standard production rates. Sailing together through the North Atlantic in mid-March were attacked by approximately 40 U-boat from 3 Wolfpacks. The battle raged from March 16 to 20, 1943. 21 merchant ships totaling 141,000 tons were sunk, the highest losses from any single convoy battle of the war. The British Admiralty issued an internal assessment that Germany had never come closer to severing Britain's Atlantic lifeline, but the cost to Germany was unsustainable. The U-boat attacking these convoys lost one boat definitively, U-384, with several others damaged. However, the broader March statistics showed 12 to 15 U-boat lost during the month, depending on classification methodology, with many losses occurring in areas outside the major convoy battles. The mathematics were inescapable even when achieving tactical success in sinking merchant ships. The strategic picture was deteriorating. Allied shipyards, particularly the rapidly expanding American construction program, were producing merchant vessels faster than Hubert could sink them. The Liberty ship program had reduced construction time from over 200 days in 1941 to an average of 42 days by 1944. While individual ships like the SS Robert E. Epperey were built in record time, 4 days, 15 hours, and 29 minutes in November 1942, these were propaganda achievements rather than standard production rates.
What really impressed me was realizing that America built over 15,000 of these complex machines while fighting a two-ocean war. Each one required an engine more complex than anything Germany produced. Yet they built them faster than we could build simple fighters. That's when I knew we never had a chance. Those guns, we called them Roosevelt's piano because of the sound they made. Once you heard that sound, you never forgot it. Many of my friends heard it for the last time. The P-47 didn't just defeat the Luftwaffe, it destroyed it. The P-47's design represented American industrial philosophy perfectly. Brute force engineering backed by unlimited resources. Every component was overbuilt, overpowered, and over-engineered. The wing spars could support 40,000 pounds, 3 times the aircraft's loaded weight. The engine mount could withstand 12 G-forces.
Nevertheless, American yards were launching approximately 3 Liberty ships every 2 days at peak production, a rate of roughly 1.5 ships daily. German Hubert sinking an average of 3,000 to 5,000 tons per boat before being destroyed could not match this production rate. As long as Allied shipyards could replace losses faster than Hubert could inflict them, the campaign represented strategic defeat, disguised as tactical success. The only way to win the tonnage war was to maintain an unsustainable exchange ratio, while simultaneously avoiding losses that Germany could not replace. The true catastrophe came in May 1943, the month that would become known among U-boat crews as Black May. Throughout the month, Allied aircraft and surface escorts equipped with Sentiment-RIC ASV, Mark III radar and Type 271 shipboard radar savaged the U-boat force with unprecedented effectiveness. The convoy battle for ONS-5 in late April and early May marked the turning point. This slow convoy of 43 merchant men, protected by 16 escorts, was attacked by approximately 30 U-boat. The Germans managed to sink 12 to 13 merchant ships but lost 6 to 7 U-boat with an additional 5 to 7 severely damaged. For the first time in a major convoy battle, the U-boat suffered losses approaching their successes. The exchange ratio had become unsustainable. 2 weeks later, Convoy SC-130 demonstrated complete Allied dominance. Of 37 to 38 merchant ships in convoy, 0 were lost despite attacks by 25 to 33 U-boat from 3 patrol lines. The German forces lost 3 to 5 U-boat, including U-954. The decisive Allied victory represented the last seriously threatened convoy of 1943. Throughout May, the losses mounted relentlessly. On May 4th, U-209 was sunk in the North Atlantic with all 46 crew lost. On May 5th, U-447 and U-663 were both destroyed. May 6th saw U-465 and U-563 sunk. May 11th brought losses of U-89, U-86, and U-456. May 12th saw U-528 depth charged with all hands lost. May 15th brought the destruction of U-176. May 19th saw the loss of U-273 and U-954. The loss of U-954 on May 19, 1943, carried particular personal weight for Admiral Donitz. The Type 70 CU boat, commanded by Kapitän Leutnant Otto Loh, carried among its crew Lieutenant Zuri Peter Donitz, the Admiral's youngest son, serving as watch officer. The boat was attacking convoy SC-130 when it was detected by the River-class frigate HMS Jed and the class sloop HMS Sanan. The British escorts prosecuted the contact with Hedgehog anti-submarine mortars and depth charges. The Hedgehog weapon introduced in 1942 represented a significant tactical advance over conventional depth charges, rather than exploding at preset depths. Regardless of whether they hit the target, Hedgehog projectiles exploded only on contact. This meant that when explosions occurred, they confirmed a hit rather than simply disturbing the water and making sonar tracking difficult. U-954 was destroyed with all 47 crew members killed at coordinates 54.54 north, 34.19 west.